Good morning. Welcome to our subject CMPE 352, Data Structures and Algorithm. For this morning, we're going to discuss Module 1. It speaks about the introduction to data structures and algorithm. Learning outcome. At the end of this module, you are expected to discuss the concept of data structure, identify the different data structure, differentiate linear from nonlinear data structure, describe the different operations in data structure, describe the different characteristics of linear data type data structure, describe the different characteristics of nonlinear type, and lastly, discuss the concept of algorithm. So, let us first define what is data structure. So, a data structure is defined here as a particular way of storing and organizing data in a computer that it can be used efficiently. So, a data structure particularly is it's typical to a storage bin where we kept our data and organize our data in order for us to find it more efficiently to use them and apply them in programming. So what is data structure? It's a representation of data and the operations allowed on that data. So it's the representation of the data. So how does the data would look like and the different operations that you can perform for this data. A data structure is also a way to store and organize data in order to facilitate access and modification. So we can see clearly that with the data structure, we can find it more easier to access our data and we can easily modify or simply update the data with less time to do that. The data structure will also be defined as a method of representing the logical relationship between individual data elements related to the solution of a given problem. That's why the data structure is to be taught as well as the algorithm, because this best describes how the data would be represented as well as the operation that data needs to be performed. Now, see in this particular diagram, we can actually look at this as the diagram that simply shows the different categories of data structure, and among the different categories we have different types belonging on that particular category, starting with the linear data structure. So under the linear data structure, we have arrays, linked lists, stacks, and queues. And for the nonlinear data structure, we have graphs, trees, and hash tables. So by looking at this diagram, we can see that there are two big groups of data structure. Now, one is called linear. Why linear? Now, it has something to do with how we organizes the data in that particular data structure. How do we keep the data in that particular data structure? In the next slide, we'll be able to see now the clear picture of what linear data structure is. So a linear data structure, or a data structure, is said to be linear if the elements form a sequence or a linear list. So from the definition, we can see that the data are being arranged in a manner that they are put into sequential, no, pagkakasunod-sunod. So there's an order by which the data are being kept from one another. Now, typical example are arrays, linked lists, stacks, and queues. So all of this data structure mentioned here actually corresponds to how the data are being stored from one another in terms of the data structure. So there must be a sequence. So sequential. So sunod-sunod. So there is a consecutive placement of data from one data to another. Okay? So that's linear. Pag sinabi naman natin non-linear data structure, it is the opposite. A data structure is said to be linear if its element does not form a sequence. So, it doesn't conform to a sequential pattern or a linear list. So, there's no particular order by which how the data will be kept or stored. So, it can be kept to any pattern or any sequence you may want to. So, under this, we have trees, graphs, and hash tables. Now, take note that each element may be connected with two or more other nodes or items in a non-linear arrangement. So, it doesn't conform to sequential or pagkakasunod-sunod, consecutive arrangement of data is not true with non-linear data structure. So, this is a pictorial representation of how your data structure would look like. So, on the topmost part diagram here, illustrate an array. So, we can see that the array is a consecutive location, or each cells conform to where the data element will be kept are arranged in sequential or consecutive manner. Okay? The next one is what we call the linked list. Now, the linked list may be compared to a chain of cells, no, wherein one cell is connected to another cell. No, this is linear fashion. So therefore, a linked list is a linear data structure. Queue is also an example of a linear structure. So queue in Tagalog is pila. So pag pumila ka, di ba, it's in order, so magkakasunod-sunod. There is a order that must be maintained in a queue. Likewise, in a stack, no, the stack is said to be a repository of data where we normally take one data at a time. And then lastly, the tree here, the tree representation here is not actually a linear data structure, but rather a non-linear data structure. Okay? So, what are the different operations that you can actually do with this data structure, whether they are linear or non-linear? So, we will be using the term traversal or traversing. So, when you say traversing or traversal, it simply means that you'll be moving from one node or one data element to another in a data structure. Likewise, here, it is said it's a way to travel through the data structure. So, the movement you'll be doing from one node to one data element to another is what we call traversal or traversing. Now, another form of operation that you can actually do with data structure is the search. So, from the word search, you can actually look for, no, a typical data element in the data structure. So, if you want to look for a particular data element, then you can traverse each element by checking whether it conforms to the search pattern you would want to do. And then insertion is another process by which you can add new data elements to the data structure. So that's what we call insertion. So this is opposite of what we call deletion. So deletion naman is you're going to remove an element or a node in a data structure. Now another operation is that you can actually do with your data structure is sorting. Sorting is a means of arranging the elements in a typical order. So there must be a typical order by which you're going to arrange the data elements of a data structure. And lastly, merging. So when you say merging, you're going to combine two similar data structure into one. Okay, so you get to experience all the operations later as we go on with this particular course. Now, let's now go discussing each characteristics of the linear data structure, starting with the array. Now, since in this subject, data structure, the programming language that you're going to use from beginning to end is Python programming. And in Python, we don't use the term arrays, but rather we use the term list. That's why here I did mention that arrays, this is actually synonymous to list in Python. So what is an array? So basically when we say array, it's a sequence of n items of the same data type that are stored contiguously in a computer memory and made accessible by specifying the value in the array's index. So, an array or a list is simply a collection of data types or data of different. Take note, we're talking of list in Python. In Python, as what we have studied last time in programming logic and design, said that in the list, it allows you to store data of different type. But here, in the arrays terminology, it is made sure that the data must be only of the same type. And they are stored contiguously. When you say contiguously, consecutively, occupying a memory location and made it specified or specifying the value inside the array's index. So in a list, we use the square bracket to denote the index. So what does the index tells? It tells specifically where we can locate a particular element on the list. So that's what an index does in the list or array. So what are some properties that you can actually have whenever you use lists or arrays in data structure? So arrays comes with fixed length. So fixed length, the moment you set the size of that array, then that will be the number of elements that you can actually store. You can no longer add. Then, another property is that it occupies contiguous memory location. Means it should be consecutively. The arrangement of the memory location will be consecutively or sequential. And then, it can be used as direct access, or you can direct access the data by simply specifying the array index. And lastly, you can insert and delete. So, on the lower part of this slide, you can see the pictorial representation of an array. So, on the topmost part of the diagram, illustrate that this is actually an array named A. And take note, the subscript or the index is being introduced in order to specify the precise location where the data element are stored, such that 2 or integer 2 is stored at the second. Now, the second location, which is represented by the index A subscripted by 1. Okay? Now, take note that the first element will always be occupying the 0 index. So, we start with 0, and then the last index will always be equals to the number of elements minus 1. So, if there are 10 elements, so the last element will always be 10 minus 1, which is 9. Okay? So, that's what we mean by the n minus 1 there. So, the last element, so the first element will be equal to index 0, and the last element of the list will be equal to the formula n minus 1, where n equals to the number of elements that are stored over the array. Okay? Then we have now the linked list. So, like I've said, the linked list is like a train, no? Train, wherein one couch is being connected to another couch until it reaches the last couch that is actually connected. So, how do we define a linked list? A linked list is a sequence of zeros or more nodes containing two kinds of information. That's why here you can see it from your diagram. The diagram shows that a node, so we call this one block a node, is being divided into two parts. The red one called the pointer, and the red one is the data, and then the white covered of the node, colored node, represents the pointer. The pointer points you to the next node location where it is actually located to. Okay? So here we have 1, 2, 3, 4, 5, 6 node. At the latter or at the last node, we will see that this is the terminal symbol, indicating that this is the last node. Ito yung symbol na yan. Parang ground, no? The ground symbol illustrates that this is the last node of the linked list. Okay? Nothing follows after. Now, what are the properties, some of the characteristics that dynamic in length. When you say dynamic in length, in linked list, you don't need to worry about the size. So unlike arrays, when the size has already been set as that size, then you can no longer, adjust it. But in a linked list, since this is dynamic in length, it means that the size can actually grow up or shrink. So pwede siyang humaba, pwede siyang migsi. Okay? And then the properties, another property is that arbitrary memory location. So when you say arbitrary, based on how we're going to point where the next node is, so that will be dependent to the pointer. So the pointer will be the one that will tell where will be the next node location. And then access by following the link. So you just simply, to access all the data or the node, you just simply move from one node to another. Likewise, in linked list, similar to array, you can insert and delete. That's why here it is said that it's dynamic in terms of its length. No, it changes as the program progresses. No, nagbabago siya talaga sa size. And then the next one, after the linked list and array, we have now the stack. So ano ba yung stack? So basically, a stack is a data structure that uses the last in, first out principle. So you may look at the stack as if it's a pile of plates, plato, no? Isang hilera ng plato, or you may compare your stack to a pile of books, wherein you cannot take the bottom part book kasi hindi mo makukuha because napatungan siya ng ibang libro. So what do? We implement the so-called principle last in, first out. So yung pinakaibabaw, yun ang unang ilalabas mo sa stack. Okay? So what are some properties? So the properties is that insertion and deletion can be done only at the top. So dito lang tayo laging maglalagay ng data at dito rin tayo maglalabas ng data lagi sa ibabaw. Okay? So it conforms to the principle of last in, first out. And basically, when you work with stack, there are only two operations that you can actually do. Push means you're going to put or store a data to the stack. And when you say pop, you're going to read a data out of the stack. Okay? So these are the two operations that you can actually work with your stack. Okay, then we have queues. So, ano ba yung queues ulit? Sa Tagalog, ito yung pila. So, it's a collection with access only to the item that has been present the longest. No? So, the longest. So, dito, if stack operates on a last in, first out, queues operates on the principle of first in, first out. Kung sino na una sa pila, syempre, siya una yung mapaprocess, siya una yung lalabas. No? It's actually the counterpart of a stack. Okay? So, similar to stack, okay, it has two operations. In queue, no? In queue is you're putting yourself into the queue. DQ means you're going to remove it from the queue. Kaya nga dito, sa taas, insertion or in queue, you're actually putting. Saan ka magpuput? Hindi sa unahan, no? So, pag pumipila ka ba, doon ka ba sa unahan pupunta? Hindi. Pupunta ka doon sa hulihan. You always add or insert a data element at the rear or back, no? So, in queue is insertion. DQ means deletion. You're deleting, you're moving an element or an item from the queue. Okay? So, normally, you remove an item in front, but you add an item at the back. So, that's basically the principle of how you're going to work with queues. Okay, now let's go to nonlinear. So, in a nonlinear data structure, these are data structure wherein we said that the data are kept or stored in no particular order or non-sequential. Hindi magkakasunod. No? Examples, we have graphs, trees, and hash table. So, here we have the graph. So, basically, pag sabi natin graph, it consists of an interconnected set of data items. No? Kung titingnan natin yung network, no, the local area network or simply the computer network, it conforms to what we call graph principle, no? So wala siyang particular order, basta it's connected from one point and you can move around in a graph. Then we have tree. So, tree, Tagalog, puno. So, basically, you'll be meeting here the root, the leaves, no? So, you may compare it also to a family tree, wherein there's the parent and there's the child node. So, a tree is a way of representing the hierarchical nature. So, take note of the word, hierarchical. So, top-down structure or organization in which the nature of the structure of the graphical form. So, basically, you can see here how the tree would look like. So, 8 here is being said to be the root. No, root yan. Kasi lahat sila nanggaling kagad lahat kay 8. No? Now, the child node normally are those found on the leaves. Ito yun, nasa leaf, no? Nasa dulo. Yung parent is 4, node 4 and node 12 are what we call parent. No? Likewise, 2, 5, 9, and 14, 2, 9, 5, 2, 5, 9 are said to be parent as well. And the siblings are 3, 7, and 10. Okay, mga anak. Okay? So, let's now move to abstract data type. So, basically, when we study data structure, the ADT or the abstract data type is one of the particular things that you have to make concern with. Now, why? Because the ADT or the abstract data type is actually has something to do with what we call storing of data. It allows us to perform different operations as far as the data needs to be accessed and needs to be modified. So, the abstract data type is simply implemented in order for us to learn more, easier for us to implement your data structure. Okay? So, we can say that the ADT is a mathematical model. So, take note, it's a mathematical model together with various operations you define in a particular model. Now, data structure may be implemented by simply applying what we call physical implementation of ADT. No? Ano ba itong mga ADT na to? No, normally, this comprises up of what we call primitive or built-in. No, mga built-in data types. So, these are data types. So, ano ba yung data types na yan? Data types pertains to, describes to what format the data would be. And it would allow the compiler or the interpreter to know how much memory you need to allocate for that particular data type. No? So, kailangan malaman natin kung gaano karaming memory spaces that a particular data type would need to be occupied. So, tawag doon primitive or built-in. Or, built into the language which we call user-defined. Yan. So, ADT supports, of course, yung 3 pillars of object-oriented programming. That's why later, when we start writing your codes for the implementations of either nonlinear or linear data structure, the one that we'll be using now is the object-oriented. So, gagawa tayo ng mga classes and objects in particular. But this time, we're not going to use C#, but rather we'll be using Python. So, Python ang gagamitin natin in implementing the what's so-called object-oriented programming. Kasi nandiyan yung abstraction, encapsulation, and information hiding. Okay? Abstraction is simply structuring the problem into a well-defined entity by defining the data as well as the operation. Diba abstraction yon? Now, the principle of hiding the data, no? The data structure is what we call encapsulation. Now, these are the different operations that you can actually deal with whenever you work with ADT. So, every collection ADT provides a way for you to, of course, to add an item, remove an item, find, retrieve, and access the item. So, these are 3 important core operations that you can actually deal with whenever you work with your abstract data types. No? Okay, so let's now proceed to algorithm. So, algorithm, this is not actually new to you because if you recall your programming logic and designs or the PLD subject in the first year, first sem, we did already introduce you to what we called algorithm. The algorithm is actually a systematic way by which you're going to solve a problem or perform a particular task. Now here we can define it more clearer that an algorithm that is a well-ordered collection of ambiguous, no, means non-conflicting or easy to understand and effectively computable operations that when executed produces a result and holds in a finite amount of time. So the algorithm definition here is very complete, no? Of course, we can see the characteristic like well-ordered, ambiguous, effective computable, okay, result, produces result, and stops on a finite amount of time. So, an algorithm must end. It should not be an ending. It should be ending. Okay? So, what are some important features? So, I did mention already this kanina, no, in the definition. But how do we represent it? So, normally, if you recall again your programming logic and design, the best way to represent an algorithm is of two ways. It's either a flowchart, no, the one we normally encounter is the flowchart, and of course the pseudocode. And then of course we have programming languages and the natural languages. Now, the algorithm this time will be far different from how you have learned it in the first programming subject you had, no? Kasi dito, we will come to a point wherein you're going to come up with mathematical, no, a mathematical approach in order for us to analyze the algorithm. That's why here I did mention that we need to use algorithm mathematically in order to calculate the resources needed for the running of the algorithm. Now, there are two aspects by which we're going to analyze an algorithm. First one is we look at it in terms of its time complexity, and the other one is in terms of space complexity. So, pag sabi natin time complexity, ibig sabihin nun, kino-compute natin yung algorithm daw kung effective siya in terms of the computing time. Meaning, the fastest the algorithm finish, the better. Okay? Kaya nga time complexity. Pag medyo matagal, it takes time for us to get the result, then that would not be a good or promising time complexity. So, dapat the time complexity must always be shortened para mabilis. And then, the next one is what we call space complexity. Now, opposite with time complexity speaks about computing time. Of course, pag sabi natin space complexity, we're referring to the storage requirement. Ayan. So, since data is primarily is our primary concern, then we have to look at how much memory allocations or requirement does this algorithm would require in order to process. Now, of course, the lesser storage space requirement would be better among the different choices, of course. Kasi, konti lang yung gagamitin mo amount ng memory, mabilis pa siya, then okay yun. So, in that case, the algorithm is very effective and efficient. Okay? So, as a summary, a data structure is a particular way of storing and organizing data in a computer so that it can be used efficiently. Now, the data structure may be classified into two types. So, we have linear data structure and we have non-linear data structure. Now, what are those types that belongs under linear data structure? So, we have arrays or list, linked list, stacks, and queues. And for the other one, we have the non-linear data structure. So, what are those data structures that belongs to this type? So, we have graphs, trees, and hash tables. We have also discussed about ADT or the abstract data types. And lastly, we have also discussed about the algorithm. So, if you have any question, the floor now is open for you to ask question. Thank you.